Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, good day everyone. So in this video, I would like to review stiffness metric method, the summary of what actually we have learned previously. Okay, including the first one is stress analysis, followed by beam, and last one is frame analysis. Okay, we will actually go through past year's exam papers. Okay, just to discuss, just to see the pattern of the question, and then we will discuss how to solve uh, the question. Okay, so okay, let's see what I have here. Okay, so I have passes exam papers. So CS421 is actually the first code we use for indeterminate structure code CS421. So okay, let's check it. Okay. So this is flexibility method. Okay, so this is beam, this is indeterminate beam. The question is for flexibility method. Okay, can we do this do or analyze this beam using stiffness method? Okay, we can check the degree of uh, freedom, because we limit the analysis up to 3 degree of freedom, because only 3 degree of freedom we can solve for the displacement. Okay, so by looking at this beam, we will have one, two, three, four, five nodes. Node A, node one, node B, okay, node C, okay, node D, node E. So if we put the degree of freedom in constraint system, we have degree of freedom in constraint system. So we have here, here. So we have purple is for unconstrained, unconstrained. So 3 unconstrained, 4 unconstrained. This okay. So five. This question has 1, 2, 3, 4, 5. 5 DOF equivalent to sorry, 5 nodes. 5 nodes equivalent to 10 DOF. Okay, there are 1, 2, 3, 4, 5, 6, 6. Okay, six unknown displacement. 6 unknown displacement and 4 unknown reaction. Okay, so this is for unconstrained. This is for constrained. So for this question, we can analyze using stiffness method. We can get the equation, but we cannot solve the equation because there are 6 unknown displacement. Okay, so we move to another question. Okay, so this question number 4 is for moment distribution method. So we move to this. Okay, this is January 2012. This is moment distribution method, the topic that we have learned, we will learn next week. Okay, this is also for flexibility method. So, okay, we also, of course, we can analyze this using stiffness method, but we may have more unknown. Okay, unknown displacement. More than three. Okay, support. If we label for support, we are not support nodes 1, 2, 3, 4, 5, 6, 6. Unknown reaction. Unknown reaction is only four. So it is four unknown reaction. Total nodes 1, 2, 3, 4, 5, 6. 6 nodes equivalent to 12 DOF. Okay, 12 DOF. So we have 8 unknown displacement. Okay, 8 unknown displacement. So this question, okay, we cannot analyze unknown displacement directly. Of course, we can use other method. We can use okay, to solve for the unknown displacement. We have to solve 8 unknown displacement. So we cannot do it manually. Okay, we cannot do it manually. But actually, we can use it, but until we get the equation only. Okay, so this is the next question. This is beam question. Okay, this one I have actually explained in my previous video. Okay, so this question also I think. Okay, so this is pin jointed plane truss. So this is the truss. Okay, so analysis of truss using stiffness method, we normally limit to not many elements, maybe two or maybe three or maybe four. If so many elements means there are so many nodes as well. Okay, so many nodes as well. So we will get we will get many unknown displacement. We will get many unknown displacement. Okay, so from this, okay, we have one node, two node, three node. Okay, how many unknown reaction or degree of freedom in constraint system? Degree of freedom in constraint system. Okay, there are four. So four unknown reaction. Okay, it is actually three nodes equivalent to 6 DOF, and we have 4 degree of freedom in constraint system. So remaining two, okay, is for unconstrained or unknown displacement. Unknown displacement is located at C. Okay, unknown displacement is located at C. So this we can analyze. Okay, we can analyze using stiffness method easily because if we look at to the question, okay, element stiffness matrices will be K1, K2 because there are two elements only. Assemble the structure stiffness equation. Structure stiffness equation is Q is equal to KD. Okay, there's no Q naught because there's no effect of temperature as well as fabrication error. So for the non-zero degree of freedom, non-zero degree of freedom means du, unknown displacement. Okay, unknown displacement, determine reaction at support A. This means QU at support A. Okay, at support A, so it depends on the level that we put at support A. Okay, axial force in member BC is the member forces, member force. Axial force in member BC means member force. Okay, we get this from formula. So the formula is Q. Okay, one or two will be depend on how we label the diagram. Okay, how we label the diagram. Okay, the formula is AE over L. Okay, it is negative CX negative CY CY times with displacement for displacement because this is member force, member element. Okay, member element. So for one element there are four. Okay, so this is the formula. So the label that we use for uh, okay, calculating axial force in member BC will be depend on how we label the diagram. If we label, for example, okay, let's say we label this as this should be 1 2 because C is unconstrained followed by 3 4 5 6. Okay, let's say we label this as 1, this as 2. Don't forget to put the arrow because we need to have the arrow. Okay, we need to have the arrow. Then only we can identify or label the K correctly. Okay, for member BC here we have 1 2, we have 1 2 5 6 based on the arrow. Okay, 1 2 5 6. So this will be 1 2 5 6. K also will be the same. For K, it is K2. For BC, K2 will be K2 will be 1 2 5 6. So label, okay, then only we will get the single value in kilonewton because, okay, A, the unit is in kilonewton. The unit of A is in kilonewton. L, the unit of L is in meter. Unit of D is in meter. CX, CY, no unit. CX, CY, no unit. So we cancel meter and meter. So we will get, okay, in unit, the answer in unit kilonewton. Okay, so this is how we analyze. This is how we analyze this question. Okay, so we move to, okay, this is 2013. 2013. Okay, let's say, okay, this is moment distribution methods, the next chapter. Okay, flexibility method. Okay, flexibility method. Basically, as I mentioned just now, we limit the member so that we can also limit the degree of freedom. Of course, this question can also be solved using stiffness method, but we have more than 3 unknown reactions that we cannot solve it manually. Okay, but we can use this type of question to analyze using flexibility method because in flexibility method we will determine the redundant first. The redundant is forces, not displacement. But in stiffness method we determine displacement first. In stiffness method we determine displacement first. So once we get displacement, then only we can get reaction. Okay, so we move to the next question. This is for flexibility method. So same goes to this because we have more than 3 unknown reaction. No, unknown displacement. We have more than 3 unknown displacement. Unknown displacement. So this question is not suitable to solve using manual calculation of stiffness method. Okay, we can solve it using stiffness method, but we cannot solve for unknown displacement manually. Okay, we move to the next question. Okay, this one I have also explained how to analyze this in my previous video. Okay, so next. Okay, question number 5. This is quite simple. Okay, this is quite simple. With only 10 marks. Okay, stiffness metric method is only two elements, so 6 degree of freedom. It is six. Okay, 6 degree of freedom because there are three notes. Three notes equivalent to 6 degree of freedom. Okay, so okay, labeling is very important. Arrow origin. So we have to put origin. So this will be 0, 0. This will be 3, 0. This will be 4, 3. So this is straightforward question. So the arrow is there. So we will produce K1 4 by 4. K1 is 1256. This is 1256, 1256. And then we have K2. Okay, use the formula to calculate the value inside the matrix. It is 1234. It is 1234, 1234. Okay, stiffness equation. Stiffness equation. So we have Q is equal to KD. Okay, it is 6 is equal to KD. Displacement. No settlement. No settlement. Is there any settlement given? Okay, no settlement. So no settlement, no temperature changes, no fabrication error. So we have there is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, we have D1 and D2 as unknown displacement. So the rest are all zero. And we have Q3, Q4, Q5, Q6 as unknown reaction. And Q1 and Q2, Q1, there's no horizontal force at B, the value is 0. Q2 is negative 150, opposite with sign convention, it is negative 150 like this. Okay, the boundary is here. So it is just like we analyze only this. Okay, so to solve for the unknown displacement, by considering only unconstrained system because displacement are all zero, so we will have only this. D1 and D2. So this is actually equal to two simultaneous equation. So using straight away using your calculator, key in the value and just give the answer. Okay. So for the unknown displacement only. Okay. Of course, you can continue to calculate unknown reaction as well as member forces if you need. But to answer this question, you just need to give up to unknown displacement D1 and D2. Okay, so let's move to the next question, 2013. Okay, for 2013, okay, let's see. Okay, this is moment distribution method. This is for flexibility method. Okay, this is for flexibility method. Okay, let me check whether we have at least maximum 3 degree of freedom in unconstrained system. If more than that, we cannot do it manually. Okay, for the reaction at the support, we count as degree of freedom in constraint system. So fixed, we have to count 2. Okay. I think I have discussed this question in my previous video as well. Okay, so the purple is unconstrained. So two unknown displacement, four unknown reaction. It is 6 degree of freedom. Come from 3 nodes. Okay. Okay. This question, support D rotates by 30. So this is actually the support settlement in beam. Support settlement means that, okay, as usual, degree of indeterminacy, DOI, degree of, okay, so this is flexibility method question, but we can also solve this using stiffness method. And in the question, there is a, uh support settlement value. Okay, support D rotates by 30 over EI. Counterclockwise is actually support settlement. This is support settlement. Support settlement. Okay, this is support settlement. Okay, this is support settlement. So how to analyze this? So as usual, the first thing to do, okay, this is flexibility method question, but by looking at the diagram, we can actually solve this using stiffness method because number of unknown displacement here, okay, is 2. Okay, is 2. So no. Wait a minute. Wait a minute. Okay. So at C, since this is representing moment at C, which is equal to 200 clockwise, and there's no formula to consider or to calculate for member BD, the fifth end moment for member BD. So C must be the nodes A, B, C, and D. So having this, we have 4. We have 4 and 8. So we have 4 also here. Okay, so this question we cannot solve it using manual calculation. But I like this question. So what I want to do is I want to modify a bit. I want to modify a bit. So it is like this, right? UDL, UDL. Okay. I want to put one roller here so that I can reduce number of unknown displacement. So moment is remain. Okay, this is 200 and then 10 and then this is 2 EI. Okay, the rest is EI. And then for the length, okay, we have 643. This is 6 meter. This is 4 meter. This is 3 meter. 643. So number one, not number one, not number two, not number three, not number four. Okay, why I want to, okay, make amendment to this question because I want to show to you how we analyze this, okay, this support D. It is support D or note number 4. Okay, so we will have the stiffness equation. Q is equal to KD plus Q naught. Okay, total must be 8. Okay, 8. equal to KD plus Q naught. Okay, so from this, okay, reaction, we have reaction, okay, this is also reaction and reaction also at number 3. So we have this unknown displacement and unknown displacement. So this is 1, 2, 3. Okay, so this is 1, this is 2, this is 3. Okay, 1, 2, 3, 4, 5, 6, 6, 4, 5, 6, 7, 8. Okay, so we will have Q, okay, Q1, Q1, Q1 is 0. Okay, looking at the diagram, Q1 is 0, Q2 is also 0, Q3 is negative 200, opposite with sign convention. Okay, then we have Q4, Q5, Q6, Q7, Q8. Okay, then we have here 1, 2, 3, 4, 5, 6, 7, 8. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, for displacement, we have D1, D2, D3. Okay, the moment at D, rotation at D, okay, 30 over EI clockwise. 30 over EI clockwise. So we label as 8. Okay, as 8. So the rest are all 0. 5, 6, 7, 8 is negative or positive. It is counterclockwise. It is counterclockwise, so it is positive. 30 over EI. It is 30 over EI. 30 over EI. And then we have Q naught that we need to calculate, which come from Q naught come from member AB or member 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we have equivalent nodal forces. Equivalent nodal forces we get from member number 1, Q, Q1 naught. We get, the label is 4512. 4512 we get from 10 and 6. It is 10 and 6. 10 and 6. 10 and 6. So it is 10 times 6, 60 divided by 2, 30 here. And WS squared over 12. W is 10. L is WL squared over 12. It is 30 as well. Okay. So we put into this. Okay, the value is 4 is all 30. 30, 30. So which one is negative? This is the negative value. and it represents 2. So this is okay, negative. So we have 1, 2. Q, remember that Q naught is equal to Q1 naught plus Q2 naught plus Q3 naught, and Q2 naught and Q3 naught are all zero value because no force subjected on member except element number 1, member A, B. So we have 1, 2, the value here. This is 30, negative 30. And then 0, 0, 5, 6, 30, 30, 0, 0. Okay, so this is actually the stiffness equation. Stiffness equation. So I have actually discussed on this how we analyze stiffness equation whenever there is a support settlement. Okay, don't forget K that we produce is also in terms of EI. So EI will be cancelled in the analysis. Okay, EI will be cancelled. Okay, so this is how we analyze this question. So don't forget we have to consider this value times with this value. Okay, because it is line times row. The idea why we don't have to consider the degree of freedom in constraint system whenever there's no support settlement, because all value when we time with 0 we get 0. But from this, when there is a support settlement and support settlement occur at position number 8, we label as 8, so we have to put displacement at position 8. So the k value at position 1, 1 8 and 2 8 and 3 8, okay, must times with this 30 over EI. Okay, then only we can proceed. Okay, so this is about stiffness method for beam considering support settlement. Support settlement. Okay, so we move to the next question. We move to the next question. Okay, distrust. So distrust, actually, I have also made a video explaining about this. Okay, so I believe this is enough for this time. The revision of stiffness equation. Okay, I focus on the past year's exam papers. Okay, I have explained how we going to analyze question regarding thrust and beam using stiffness method. Okay, of course, the first thing is we need to identify number of unknown displacement, because we can only uh, calculate unknown displacement up to 3 degree of freedom. Okay, up to 3 degree of freedom. Of course, uh, doesn't matter how many unknown displacement we have, but if we have more unknown displacement, more than 3, means that we can only solve until the stiffness equation, but we cannot solve the answer. If we have 2 or 3 unknown displacement, then only we can solve for the unknown displacement before we can calculate the reaction and the support as well as member forces in the class. Okay. So don't forget, if it is thrust, if it is thrust, Q naught will be available whenever there is the effect come from temperature changes or fabrication error. Or fabrication error. Okay. And in trust as well, if we have support settlement, so this is how we analyze the support settlement. Okay, so I have actually discussed or explained in full solution in my previous video. There are many videos that I have made. So I wish uh, every student should watch all the video, and I believe after you watch the video, you do exercises, and then you will be able to score for your test this Sunday. Okay, so that's all for this video. Inshallah, we will meet again in the next video, in the next chapter. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh.